Hello, and my name is Adrian Arcuri, and welcome to my 20-minute lesson. Now, I just want to start off by saying that this isn't ideal on this is not how I would normally approach this. I've been on a staff leadership retreat for the last 2 days, and I'm just trying to get this in before the 48-hour deadline. So I apologize if it's not, the right way of doing this. It's also not how I would present it. I would have preferred to have live drawings going through it, but that's okay. So, starting now. Today's lesson, we're going to look at solving simultaneous equations using substitution. By the end of this lesson, I want you to be able to correctly change the subject of equations and substitute equations and then solve them. So if we have a look at the text there, this is the instructions that we're going to go through today. So let's get out a highlighter. And it says there, we can also solve simultaneous equations using the substitution method, which involves substituting the x or y variables from one equation into the other equation. So those words are in bold. If we highlight those, today we'll be looking at the substitution method. So we should have some pre-context from Year 9 maths about the substitution method. But there's an example underneath it, so we'll keep reading. This method is generally used when at least one of the linear equations has x or y as the subject. So for example, y equals 3x plus 4 and 3x plus y equals 2. Okay, and then we see the other two examples there. Okay, so it has the subjects. The steps that we take for this, we can use the substitution method using the following steps. Solve one equation for one of the variables in terms of the other. Substitute this expression into the other equation and solve, and then resubstitute the value into the original equation to find the other variable. So if we have a look at the examples. Now, that may sound a little bit challenging, a little bit daunting to start off with if we're unsure, but we're going to go through the examples and I'm going to show you where the steps are used. So if you look at step 1, it says solve one equation of the variables in terms of the other. Okay, so what you want to do is you want to break up the question into two sides. So you can see here it says y equals 2x plus 1 and then y equals x plus 3. The subject for both equations is y. So therefore, we can substitute 2x plus 1 into the y on the right-hand side of our page. So our new equation becomes 2x plus 1 equals x plus 3. And that way, we are able to get the same subject in the one question. So now we're only solving for x, and we can use simple algebra to solve for x. Okay, so now we've got 2x plus 1 equals x plus 3. All right, we can minus 1 from the left-hand side onto the right-hand side. So now it's x, 2x equals x plus 2. And then we can determine from there that x equals 2 by minusing the x from the right-hand side onto the left-hand side. So we have x on its own and x equals 2. So we've figured out the value for x, but we're not done there. Okay, so we've done step 1. We've done step 2. Now we need to resubstitute the value of x back into one of the equations. Okay, so if we look at the right-hand side equation, it says y equals x plus 3. We know that x equals 2, so y equals 2 plus 3, and therefore y equals 5. And if we do it on the left-hand side, just to double check our answer, we've got y equals 2, and then substituting the 2 into the x. So 2 times 2 plus 1, 2 times 2 is 4, plus 1 is 5, and y equals 5. So therefore, x equals 2 and y equals 5. Okay, we'll go through the next example. So y equals 5 minus 2x and y equals 3x plus 2. Okay, we're going to solve the equation for one of the variables. So we're going to put 1 on our left-hand equation and 2 on our left-hand equation. Now, once again, the subject is the same. So y is the subject on both sides. So we can therefore substitute 5 minus 2x straight into the right-hand side equation. So it's 5 minus 2x equals 3x plus 2. Now we only have x to solve for our equation. So once again, we are looking at the left-hand side. So we have a positive 5. We can take that away on the other side. So it's 2 minus 5, which equals negative 3. So therefore, we have negative 2x equals 3x minus 3. Okay? Then we want to get x on its own. So we're going to get that negative 3x over to the other side. And then we're going to have negative 5x equals negative 3. And then we're going to divide negative 5 and get it to equal negative 3. Now, I've put this equation in purposely to show that it is okay if we get a fraction. All right, we might get an ugly number. It's not the end of the world. So therefore, x equals 3/5 or 3 over 5. We now substitute that x back into our original equation. Okay, so we get y equals 3 times 3/5 plus 2. Put that in our calculator, we get y equals 9/5 plus 2, and then we get it equals 19 over 5, or 3 4/5. Now we need to write out both our answers, so therefore x equals 3 over 5, and y equals 3 4/5. Okay, and you can see on the next slide how I would complete that equation or that task. You can see the steps that I've taken. So this is how I would be doing it with the kids as we go through the question and following those 1, 2, 3 steps. I like to use different colors to showcase different things when we're breaking down the question, when we're minusing and going across both sides, going across the equal sign, so that they are able to grasp the concept. All right. Now, I want you to pick an example that you want to go through. You look there and you try and pick maybe the hardest one or one that you want to go through. All right, you want to go through example E? All right, let's go through example E. Tell me what you would do first. All right, we've determined our two sides. Well done. You got one on the left-hand side and 2 on the right-hand side. Okay, now what are we going to do? Good, we're going to sub in the y value from the left-hand side into the y on the right-hand side, so we're only dealing with an x value. So we are now going to have 3x plus x minus 2 equals 18. All right, now what do we do? That's right, we collect like terms. So we have 3 plus x minus 2 equals 18. Okay, 4x minus 2 equals 18. Then the plus the 2 to the other side, 4x equals 20, and therefore x equals 5. Are we finished there? No, we're not. Now we have to sub x into one of our original equations, and we can sub them into both just to make sure. So y equals 5 minus 2. What does that equal? It equals 3. So y equals 3. And we can sub both those values into the right-hand equation just to make sure. So 3x is, we subbed in the 5, so 3 times 5 is 15, and we've subbed in that y equals 3, and therefore 3x plus y equals 18. 15 times 3 equals 18. We are all correct. All right, pretty simple. I want you now to go through and finish off the questions on that page so that we can have a fully understanding of that. And this is where I would follow the same process. I would guide them through the questions and then get them to show full working out. If they're struggling, then I would obviously deploy different methods. I'd like to deploy guided methods where, what do you do next? Make them think about it. Have a go first once I've gone through the explanation. Make sure that they can have that grasp of understanding. and then we go through and answer each question together. And then we'll move on to some worded problems within simultaneous equations. All right, so when solving worded problems, it can become a little bit more difficult. Okay, we need to be able to either have a highlighter. If we don't have a highlighter, we can still underline with our pen. Okay, and we need to be able to have a make sure we're reading the question properly. So RUTAC. Okay, so when solving worded problems, use the following substitution method. Okay, define, describe two unknowns using pronumerals. So this is where if we have names or anything, states where we've had to do some addition, subtraction, multiplication, we use a pronumeral. So pronumeral is just a letter in mathematics. Okay, we write down the two equations simultaneously using pronumerals. We then solve and answer the original question in words. Okay, so looking at this question, Jade is 5 years old. Jade is 5 years older than Marion. If their combined age is 33, find their ages. Okay, so the key terminology that I would highlight in that question is Jade, and turn that into a J, is 5 years older than Marion. I'd highlight that, 5 years older, and then Marion. Okay, and I would use M for Marion, so J for Jade and M for Marion, and then highlight combined age is 33. Fine, and then we can circle find their ages because we're circling the end product, what they want us to find, the final answer. Okay, so we've got our key content highlighted, and we've circled what they need us to find. So we've got Jade is 5 years older than Marion. Okay, as an equation, how can we write that down, do we think? All right, so what I would do is I would do J equals M, and how many years older is her than Marion? She's 5. So it's M plus 5. J equals M plus 5. Okay, then it says their combined ages is 33. What's another way of saying combined? If we put two things together, what are we doing? That's right, we're adding them. So therefore, J plus M equals 33. And when we write that out, we can see that we have J as a subject in one of our equations. So we can therefore substitute that equation into the other. So we've got M plus 5 plus M equals 33. Okay? We then collect like terms. So we've got two M's in there and it's addition. So it's not M squared, it's 2M plus 5 equals 33. We then take away the 5 from both sides and we get 2M equals 28. We then get M equals 14 when we divide the 2 on both sides. So now we've got Marion's age. Are we done there? No, we're not. We're going to substitute that 14 back into one of our equations. Okay, so we've got J plus equals M plus 5. I'm going to put that 14 in there. So J equals 14 plus 5 and J equals 19. Now, with a worded question, we're not finished there because it's asking us to find their ages and we have to answer back in the original question in words. So we write, therefore, our three little dots as a triangle. Marion is 14 and Jade is 19. Okay, and that's how we would answer a worded question. All right, let's go through example 27 together. So at an art show, there were 520 guests. If there were 46 more women than men, how many more women attended the show? What would you highlight there? All right, so we've got 520 guests, that's right. So highlight 520 guests. And there was 46 more women than men, that's right. And what are we going to circle? How many more women attended the show? So this one's a little bit different. It's not asking us for their combined ages and to find their ages or to find just the amount of men and women. It's asking us how many more women attended the show. Oh, sorry, not more. How many women attended the show? And that's what happens when you don't read the question properly. All right. So how many women attended the show? I was just adding in more there for no reason. All right. So simultaneous equations. Let's get our two equations out there. All right. So there was 46 more women than men. So if we make, actually, how would you do it first? So you would get the W as the subject, and it equals M plus 46. That's right, because you've got more males. You've got 46 more women than males. So 46 more is an addition. All right. And the total guests, how would we write that as an equation, do you think? W plus M. That's right, because we've got men plus women equals 520. Now in one of our equations, we've got W as the subject. So what are we doing now? That's right, we're subbing it in to the equation. All right, so we've got our equation of W plus 46, because we're subbing our M into that W plus M, the subbing it in, plus M equals 520. Now we're going to get like terms, so M plus M equals 2M, and then plus 46 equals 520. We minus that 46 from the 520 because we're going across the equal sign. We swap the sign. All right, and 2M equals 474, and then you divide that by 2, and it's 237. So now we've got the number of males. What do we have to do? That's right. So sub that in. Sub in M, as you've said, sub in M to one of the equations. Okay, so W equals 237 plus 46, simple addition, and we get W equals 283. Now, we've got our men and women. What's our last step? That's right, we're going to sub it in. We're going to write it in the words. Okay, so therefore, our three little dots, there were 283 women at the show. Okay, and there is our working out together. Now, this is how I would do it with the kids on the iPad or on a sheet. Underline exactly what I've said. You've got the circles around what the worded answer needs to be. Okay, you got the underlines, you got the highlights of the matching colors with changing the subject. That is how I would teach that subject. As I said at the start, not exactly how I wanted to present this lesson, but it's been a bit chaotic. I hope that you find this useful, and I'm looking forward to hearing back from you.